What's up everyone? Welcome back. Today's video is honestly one I have been wanting to make for a long time. We are talking about the single most profitable AI skills you can learn in 2026. Not prompt engineering, not fine tuning. It's RAG, Retrieval Augmented Generation. By the end of this video, you will understand exactly how it works, where most developers mess it up, and how this one skill can take you from 0 to a 10 LPA job. Let's get into it. Look, here's the truth that nobody tells you when you're starting out. Every LLM, GPT-4, Claude, Gemini, they all hallucinate. They make up facts with complete confidence. And here's the crazy part. There are three specific ways this destroys real products. First, their knowledge has a cutoff date. They literally don't know what happened last month. Second, they can't access your internal documents or company data. And third, they will confidently lie to your users. That's a product killer. RAG fixes all three of these. So, what exactly is RAG? The simplest way I can explain it, RAG is a technique where instead of asking the LLM to remember everything, you give it the right information at the right time. Think of it like an open book exam. The formula is simple. Your documents plus LLM reasoning equals grounded, factual answers. You store your docs, you search them semantically, the LLM reads the relevant parts and it gives you a cited answer. That's it. Four steps, but the devil is in the details, and that's what this whole video is about. Now, before we go deep technical, let me show you why this skill specifically is worth your time. RAG engineers in India are pulling 10 LPA and above in 2026. I'm not making this number up. Check Naukri, LinkedIn, Angle List right now. And here's why the demand is so insane. Every single enterprise company is trying to build an internal AI chatbot on their own data. Every startup building on LLMs uses RAG as their core pattern. And the beautiful thing is, it's complex enough that most developers give up halfway. That complexity is your opportunity. Alright, let's build this from scratch. The basic RAG pipeline, what I call naive RAG, has exactly 5 steps. Step 1, you load your documents. Step 2, you chunk them into smaller pieces. Step 3, you convert those chunks into embeddings, basically math vectors. Step 4 is when a user asks a question, you retrieve the most relevant chunks. Step 5, you pass those chunks to the LLM and it generates the final answer. Now, here's what I really need you to hear. 80% of developers build this, put it in production, and wonder why it fails. Because this is just the foundation. The real skill starts after this. Let's zoom into each step. Step 1 is document loading. Your pipeline is only as good as the data you feed it. And the cool thing about langchain is it has loaders for literally everything. PDFs for PDF loader, web pages for web based loader, CSV files, CSV loader, JSON API, JSON loader. In practice, most enterprise rack systems are ingesting PDFs and internal wikis. So get comfortable with PyPDF loader first. That's your bread and butter. One thing you nobody tells is always clean your documents before loading. Remove headers, footers, page numbers, garbage in, garbage out. Step 2, and this one is massively underrated, that is chunking. How you split your documents determines everything about retrieval quality. You have three main strategies for this. First is fixed size chunking. You say chunk size equals 1000 characters, overlap equals 200. It is simple, fast, work for most cases. Next is recursive chunking. Langchain's recursive character text splitter. This tries to split on paragraph breaks first, then line breaks, then spaces. This is the one I use in 90% of my projects. And semantic checking. It actually detects topic shifts in the text. Most powerful but slower. Now, pro tip is always set an overlap of 10 to 20%. Without overlap, you lose context right at the boundary between chunks. I have seen this kill retrieval quality in productions many times. Step 3, Embeddings and Vector Databases. This is where the magic happens. When you have a chunk of text, you run it through an embedding model like OpenAI's text embedding 3 small, and it converts that text into a list of numbers. A vector, 1536 numbers to be precise. And here's the crazy part, similar meaning, similar numbers. So dog and puppy will have very close vectors even though the words are completely different. You store all these vectors in a vector database, Pinecone for protection, ChromaDB for local development, for FAISS for when you need zero cost. When a user asks a question, you embed that question too and find the chunks with the closest vector. That's a semantic search. Now let's see step 4 and 5, retrieval and generation. These work as a pair. On the retrieval side, you take the user's query, embed it, run an ANN, that is approximate nearest neighbor, search in your vector DB and return the top k results. There's also a technique called MMR, maximal marginal relevance, which adds diversity to your results so you don't get five chunks that all say the same thing. Then comes generation. You build a prompt template that says something, answer the question using only the following context, and you inject those five chunks into it. The LLM reads the context, generates an answer, and ideally cites which document it used. Clean, grounded, factual. Here's the topic that most YouTube tutorials skips completely. Naive fails in production and it fails in very specific, painful way. Problem 1 is wrong chunks get retrieved. Problem 2 is your chunk size was basically a guess. Too small and you lose context. Too large and you introduce retrieval noise. Problem 3 is you have zero evolution. How do you even know if your RAG is good, vibes? And problem 4 is single step retrieval completely breaks on multi hop questions. Like if I ask who found the company that acquired DeepMind, that needs two retrievals. Naive RAG can't do that. This is exactly why advanced RAG exists. Welcome to the section that separates the 3 LP developer from the 10 LP engineer, that is advanced RAG. There are 4 core updates you need to know. First is query rewriting, making the search smarter before it even starts. Second, re-ranking, taking your retrieved results and scoring them again with a better model. Third, RAG evolution, actually measuring your system's quality with real metrics. And fourth, hybrid search, combining keyword search with semantic search for the best of both worlds. We are going to go deep on each one. Let's go. Advanced technique number 1, query rewriting. Here's the problem. Users type terrible queries. How does this work? Work how? Work what? If you embed that garbage query, you get garbage retrieval. Query rewriting means you use an LLM to transform the vague user query into precise, retrieval optimized questions before you even touch the vector DB. 3 techniques you need to know. Hide, that is hypothetical document embeddings, where you generate a fake ideal answer first and embed that instead. Next is multi-query retriever, where you rewrite the query into 3 different versions and run all 3 searches. And step back prompting, where you zoom out to a broader concept to get more context. In langchain, multi-query retriever is 2 lines of code. Use it always. Advanced technique number 2, re-ranking. And this one gave me the biggest accuracy jump I have ever seen. Here's the problem with the basic retrieval. Your vector DB uses a by encoder. It embeds the query and documents separately and compares them. Fast but not that precise. Re-ranking adds a second step. You retrieve a large set, say top 20, and then you run a cross encoder model that looks at the query and each chunks together and gives you much more accurate relevant score. Then you take only the top 5 of those re-ranked results to the LLM. Cohere Re-rank is the easiest API to use. BGE Re-ranker V2 is the best open source option. Studies on benchmarks like BIR and MS Marco shows accuracy improvements of 20 to 35%. That's massive. Advanced technique number 3, and honestly, this might be the most important one for getting hired, RAG evolution. Look at these 4 numbers on screen. Faithfulness 0.92, answer relevance 0.87, context recall 0.79, context precision 0.83. These are RAG's metrics. When you walk into an interview and you can say, my RAG system scores 0.87 on answer relevance, and here's how I improved it from 0.63. That conversation is over. You get a job. Faithfulness measures whether the answer actually comes from the retrieved context or if the LLM is hallucinating, whereas answer relevance check if the answer addresses the questions. Context recall checks if you retrieved all the necessary information, and context precisions check if what you retrieved is actually useful or not. Install rags and pipes, 2 lines of integration with langchains. Do this on every single project. Advanced technique number 4, hybrid search. Pure vector search is great for semantic, but terrible for exact matches. If someone asks about invoice and the number, there's no semantic meaning there. It's a code. BM25 classic keyword search handles that perfectly, but BM25 also misses intent and paraphrasing completely. So what do? You run both. BM25 for keyword matching, dense vector for semantic understanding, and then you combine the score using reciprocal rank fusion, that is RRF. It's a simple formula that merges two ranked lists into one. Every serious production RAG system I have seen uses hybrid search. In langchain, you can set it up with ensemble retriever. This alone will push your retrieval quality noticeably higher. Now let's talk about the actual tools you need to get hired. Your orchestration layer, langchain. Learn LangChain first because most job descriptions mention it. Second, LLM provider. OpenAI GPT-4 for paid. Claude Sonnet for complex reasoning tasks. Next, embeddings. OpenAI text embedding 3 small is cheap and excellent. Next, BGE M3 is the best open source option if you want zero API cost. Next, VectorDB, Pinecone for production, ChromaDB for local dev. Next, Reranker. Cohere Rerank API, one line of code. And finally, evolution. RAGs is the standard. Langsmith for tracing and debugging your chain. This is the exact stack that's on 80% of RAG job description right now. Let me put it side by side so it's crystal clear. In query handling, naive RAG takes your query and directly embeds it, but advanced RAG rewrites and diversifies it first. In retrieval process, naive RAG does a single cosine similarity pass, but advanced RAG uses hybrid search plus re-ranking. In chunk strategy, naive RAG uses only fixed size chunk. Advanced RAG uses semantic chunking and parent-child relationship. In evolution, naive RAG is manual or vibe based, whereas advanced RAG has RAG's metrics running in your CI or CD pipeline. And in accuracy, naive RAG sits around 60 to 70% on standard benchmarks, but in advanced RAG, it hits 85 to 92%. That gap is the gap between a 3 LPA developer and a 10 LPA engineer. Alright, I'm not going to leave you without an action plan. Here's exactly how I had structured your first week. Days 1 and 2, build NiveRag, LangChain, ChromaDB, OpenAI in just a PDF you care about. Get it working end to end. Day 3, add Cohere Rerank. Test your accuracy before and after. You will see the difference immediately. Day 4, add multi-query retriever for query rewriting. Start handling vague users question gracefully. Day 5, implement hybrid search with ensemble retriever. BM25 plus your existing vector search. Day 6 and 7, add RAG's evolution and build a Streamlit UI. Deploy it free on Streamlit Cloud or Hugging Face Spaces. 7 days, one project, portfolio ready. This is your path. Let me give you the complete career arc. 0 to 3 LPA, this is where you learn Python, get comfortable with LangChain, and build your first naive RAG pipeline. At this stage, you are a beginner, but you have something working. Next, 3 to 6 LPA, you are now a builder. You know advanced RAG techniques, re-ranking, hybrid search, and you can actually evaluate with your system with RAGs. You are not just building, you are measuring and improving. 6 to 10 LPA and beyond, this is the engineer level. You are deploying to production, you understand embedding, fine tuning for domain specific use cases, and you can architect multi agent RAG systems. Most people never get past stage 1 because they don't have a roadmap. Now you do. And that's the complete RAG Masterclass. Look, everything I showed you today is learnable. It's not rocket science. It's a set of patterns and tools that you can pick up in a week if you focus. The 10 LPA role does not go to the smartest person. It goes to whoever ships first. So here's your homework today, not tomorrow, today. Open a notebook, install LangChain and ChromaDB, and build your first naive RAG on any PDF, measure it with RAGs, deploy it somewhere, put it on GitHub. That project is your ticket. If this video helped you, smash that like button. It actually helps this channel grow so I can keep making content like this. Drop your biggest RAG questions in the comment below and I'll answer every single one. See you in the next one.